Good day, everyone. Welcome to another video episode for Senior High School STEM. The aim of this tutorial is to help grade 12 students in understanding the topics in general chemistry. So get ready to learn. Take a deep breath, have an open mind, and think that chemistry is easy and fun.
Today's episode is General Chemistry 2, Quarter 2, Week 6, Most Essential Learning Competency 169, Oxidation and Reduction, Redox Reactions. This self-learning module was published by DepEd Region 6, Western Visayas. Chemical reactions form new substances. Many reactions produce combinations of atoms that require a change in their oxidation states. This means that for the reaction to proceed, electrons are transferred from one atom to another. Redox reaction and oxidation states. Oxidation states, also known as oxidation number. Reduction and oxidation, or together dubbed as redox reactions, are the foundations of electrochemistry and essentially the electrochemical industry. Chemical reactions that involve changes in the oxidation states of the atoms involved are redox reactions. Both reduction and oxidation occurs simultaneously in these reactions. Since both are the two halves of a whole, a redox reaction is usually divided into these two half reactions defined as oxidation, loss of electrons, reduction, gain of electrons. A common mnemonic used by students is oil rig. Oil, oxidation is loss, rig, reduction is gain. Oxidation states refer to the number of charges assigned to atoms in a compound. A change in the oxidation state of an atom indicates a loss or gain of electrons. To be able to determine whether a reaction is a redox reaction, as well as identify the oxidation and reduction half reactions, it is essential for you to be able to assign the correct oxidation states to the atoms involved in a reaction. See the example below for the formation of sodium chloride. I had rewritten the next part of the explanation to show it clearly. We have here the reaction. 2 moles of sodium plus 1 mole of chlorine gas will form 2 moles of sodium chloride. Sodium chloride is our common table salt. Now we will assign the oxidation states. Sodium, it is uncombined, so it will have 0. The same with chlorine, 0. Sodium ion will have +1 and chlorine or chloride ion -1. We will inspect if there is a change in the oxidation states of the element on both sides of the reaction. So, sodium from 0 to +1. Chlorine from 0 to -1. We will use this figure to easily identify if the change is oxidation or reduction by following the direction of change for oxidation upwards and reduction downwards. Now, for sodium, from 0 to +1, direction is upwards. So sodium undergoes oxidation and loses 1 electron, 0 to 1. 4. Chlorine, that is from 0 to minus 1. The direction is going down. So it undergoes reduction and gain 1 electron from 0 to minus 1. Sodium undergoes oxidation and loses 1 electron. When electron is lost, it is written in the product side. Chlorine undergoes reduction and gained 1 electron. When electron is gained, it is written in the reactant side. When lose means gain. Atoms are neutral. That means the number of electrons is equal to the number of protons in an atom. Example, we compare sodium atom and sodium ion. Sodium atom has an atomic number of 11. That means there are 11 protons and 11 electrons. Remember that protons are positively charged and electrons are negatively charged. So when these are added, it becomes 0. That is why the charge of the sodium atom is 0, because it is electrically neutral. When sodium atom becomes an ion, it loses electrons, or 1 electron. So the number of proton is still the same, but the number of electron is minus 1, which is 10. If we add this up, it becomes plus 1. There is an extra proton. That is why sodium ion has a positive 1 charge. Now for chlorine atom and chlorine ion. Chlorine atom has an atomic number of 17. That means that there are 17 number of protons and also 17 number of electrons. Now, if we add this up again, it will be 0. That is why chlorine has a 0 charge. It is electrically neutral. When chlorine atom becomes chlorine ion, it gains 1 electron. So the proton still the same, but the electron now is plus 1. So if we add this up, positive 17 and negative 18, the answer is minus 1. That means there is an extra electron. That is why chloride ion has a charge of negative 1. Based on these changes in oxidation states, another way to define reduction oxidation is oxidation, loss of electrons, or increase in oxidation state from 0 to plus 1. That is an increase. Reduction, gain of electrons or decrease in oxidation state from 0 to minus 1. That is a decrease in oxidation state. As you have seen in the example above, to be able to determine whether a reaction is a redox reaction, you should first determine whether the oxidation states of the atom involved has changed. To do so, accurately assigning the oxidation states of the atom is essential. Here are the rules that will guide you in assigning the oxidation states of the atoms in a reaction. 1. The oxidation state of an uncombined atom of an element is 0. For example, carbon, nitrogen gas, hydrogen gas, lithium, and from the previous example above, sodium and chlorine gas. The oxidation state of a single or monoatomic ion is the same as its charge. Where can we find the charge of an ion? We can find it in the periodic table. Remember, you were asked to familiarize yourself of the cations and anions during writing of chemical formulas in General Chemistry 1. So for example, sodium and sodium chloride is sodium plus 1, and magnesium sulfide, magnesium is plus 2, and sulfur is minus 2. Number 3, oxygen is assigned an oxidation state of minus 2 in most covalent compounds it forms. An important exception is when it appears as peroxide, O2 minus 2, where it has an oxidation state of minus 1. For example, O is minus 2 in water and carbon dioxide, and O is minus 1 in hydrogen peroxide. Number 4. Hydrogen is assigned an oxidation state of plus 1 in covalent compounds, for example, water and hydrogen fluoride. Number 5. In covalent binary compounds, two different nonmetals, the more electronegative element is assigned the negative oxidation state equal to its charge if it were an ion in ionic compounds. For example, hydrogen is plus 1, and sulfur is minus 2 in H2S, N is minus 3, and H is plus 1 in ammonia. Number 6. Compounds are electrically neutral, so the sum of the oxidation states of all atoms in the compound must be 0. 7. Polyatomic ions or ions formed by a combination of atoms must have a total charge equal to the sum of the oxidation states of the atoms. This will be discussed later. How we assign oxidation states or oxidation numbers. We have the example, the oxidation state or oxidation number, and the rule. Number 1 here is chlorine gas. Using rule number 1, chlorine is 0 because the oxidation state of an uncombined atom of an element is 0. Next, carbon tetrachloride. We use rule number 6. Compounds are electrically neutral. And number 5 says that in a binary compounds, the more electronegative element is assigned the negative oxidation number. So, in this case, chlorine is more electronegative compared to carbon. So, it will be assigned minus 1. How you will know that chlorine is more electronegative than carbon? Use the periodic table. Look at the electronegativity values. Okay, so minus 1 times 4 is minus 4. We need similar number with opposite charge so that this will become 0. So that would be plus 4. That is why carbon is plus 4. Plus 4 plus minus 4 is equal to 0. It is now electrically neutral because it is 0. Next, aluminum oxide. So, oxidation state of a single or monoatomic ion S, the single is the same as its charge. And remember that for rule number 3, oxygen is assigned an oxidation state of -2. That is why this is -2. Okay. Now, and remember that it is electrically neutral. Rule number 6. So, we have oxygen or oxide -2 times 3 is equal to -6. Aluminum here is 2, so to make it positive 6, we will assign aluminum with +3. +3 times 2 is +6. +6 plus -6 is equal to 0. Next, sulfate ion. Again, OS assigned with an oxidation state of -2. But this -2 here of the ion is the charge of the whole ion, SO4. Oxygen has -2, but the whole SO4 is also -2. So we will solve for the S. Because it is an ion with a charge of -2, we will also equate the equation with -2. S plus 4 oxygen times the oxidation number, which is -2, is equal to -2. This -2 is the overall charge of the ion. So S is equal to plus 4 times -2 is -8. Transpose it to the other side, it becomes +8, and then carry the -2. S is equal to +6. +8 minus 2 is +6. Next, sodium hydroxide. Again, sodium is assigned +1. In the periodic table, check your cation and your anion. And oxygen is assigned a -2 oxidation state. And H is also assigned in rule number 4 an oxidation state of +1. So we'll just have to write it here. Sodium is +1, hydrogen is +1, oxygen is -2. We'll see if it is balanced. +1 and +1 is +2, and this is -2. If we add it, it will become 0. So it is electrically neutral. Next is potassium permanganate. Potassium is +1. This is have to follow rule number 2. And you have to check out the periodic table for the cation and the anion. And remember that the compound is electrically neutral, and O is assigned a -2 oxidation state in rule number 3. So here we're gonna solve it. So potassium, just follow this format. Potassium is +1 plus manganese, that is our unknown, plus the subscript will become the coefficient 4 oxygen times the oxidation state, which is -2, is equal to 0. We equate it to 0 because this is a compound. A compound is electrically neutral, so we equate it with 0. If it is an ion, we equate it with whatever the charge here of the ion equated it. But for a compound, we equate it to 0. So manganese is equal to 4 times minus 2 is minus 8. Transposing it is plus 8. Plus 1, transposing it is minus 1. Mn is plus 7. That is why it is plus 7 here. But we can also use the shortcut. We know that oxide is minus 2 and potassium is plus 1 from the periodic table, cations and anions. Now, minus 2 times 4 is minus 8. Plus 1 times 1 here, potassium is only 1, so plus 1. So we need 7 for it to become plus 8. So that when it is added with minus 8, it will become 0. That is why manganese is plus 7. Exercises. Exercise number 1. Assigning oxidation states. Analyze each of the following and assign oxidation states to all atoms present. Write the oxidation state above the atom. Follow the example given. The example here is water. So oxygen is minus 2 from the rule and hydrogen is plus 1. So this is how you will do this 1 to 10. Exercise number 1. Next. Exercise number 2. Assigning oxidation states and identifying changes. Assign the oxidation states of the atoms present in each given reaction. Identify which atoms undergo changes in oxidation state. Follow the examples given. So the example here is methane gas plus 2 moles of oxygen gas will form carbon dioxide, 1 mole of carbon dioxide plus 2 moles of water. So again, you have to assign oxidation states. Okay, so hydrogen, remember, plus 1. Plus 1 times 4 is plus 4. So you will need minus 4 to make it 0. And oxygen gas just 0 oxidation state. For oxygen, minus 2. Minus 2 times 2 is minus 4. So carbon will be plus 4 to balance the minus 4 to make it 0. And we know that oxygen is minus 2 and hydrogen is plus 1. Plus 1 times 2 is plus 2. Minus 2 times 1 here of oxygen is minus 2. That will be equal to 0. Now, we will check if there is a change of oxidation number. So changes carbon from minus 4 to plus 4. And then you identify whether it is electron lost or gained, oxidation or reduction by using this figure. Oxidation from 0 to minus 2. So this is minus 2. So we will see minus 4 to plus 4, minus 4 to plus 4. So direction is upward. So that is oxidation, electrons lost or loss of electrons. Oxygen from 0 to minus 2, direction is going down. So that is reduction, 0 to minus 2, reduction. Electrons gained or gain of electrons. So that is how you will do it. So the same thing here. You have to assign the oxidation number and then identify if there is a change in the oxidation states, and then identify F, what is the change, okay, from blank to blank. This is electrons gained or electrons lost, and reduction or oxidation. The same with number 2, the same with number 3. Let's go to exercise number 3, identification of redox reactions. Analyze the following reactions by assigning the oxidation states of the atoms involved and determining whether the reaction is a redox or non-redox reaction. Write redox or non-redox on the space before the reaction. So I will do 1 and 2 to make it clearer to you. Okay. For number 1, KClO3 will form KCl plus O2. Now, remember that oxygen is -2 and potassium is +1. Again, look at the periodic table for your cations and anions. -2 and times 3 -6. You already have a +1, so you only need a +5 to have a +6. Chloride ion is -1, potassium ion is +1, and oxygen is 0. So look, is chlorine and chlorine a change? Yes, 5 to 1. Oxygen change 0 -2 to 0. So if there is a change in the oxidation states, it is a redox reaction. Okay? How about number 2? Na2CO3, sodium carbonate, will form sodium oxide plus carbon dioxide. Now, remember that oxygen is -2, that is -6. Sodium is +1, so +1 times 2 is +2. +1 times 2 here, there is a subscript for sodium, so that is +2. So you need only +4 to make it 6. This is 6, and this is 2 plus 4 here is +6, so that is equal. And oxygen is -2 and sodium is +1. +1 times 2 is +2, and this is -2, 0. This is -2 oxygen, -2 times 2 is +4. So carbon would be +4 to balance the negative, -4. Now, we'll see if there's a change. Sodium, +1. There is no change, +1 and +1. Carbon, +4 and +4. No change. Oxygen is -2 and -2. No change. So no change in oxidation states and the reactant and the product side. So it is a non-redox. So that is how you do it. So that means number 1 here, you just write redox, and number 2, non-redox. That's how it is done there. And the last part, some examples of redox reactions in everyday life. That means this is the application. In electrochemistry, is the field of chemistry that deals particularly with the chemical and electrical energy involved in chemical reactions. The energy produced by a chemical reaction is a remarkable source of energy that we use daily, from the battery of your gadget to the power cells that our different appliances utilize. This is a power source. Next, respiration. Cellular respiration. During the process of respiration, the carbon dioxide is reduced, whereas the water is oxidized to form oxygen. When we say reduced, that means it undergoes reduction, and oxidized, it undergoes oxidation. Combustion. During the process of combustion, the oxygen present in the atmosphere is being reduced, whereas the compound which is being burned is undergoing oxidation. Photosynthesis. In photosynthesis, water is oxidized and carbon dioxide is reduced. Thank you for watching. If you learned something from this video, please like and subscribe to my YouTube channel. God bless and stay safe, everyone.